In this video, we're going to receive an introduction to solutions and solubility. We're going to take a look at some key words that you should know for the solutions and solubility unit. So our focus is all about dissolving and then how the chemistry behind the solutions that we're going to study in this unit. So these are all the learning goals. Make sure you read through them before proceeding through the presentation. And as usual, there's a great preview of the material video that you can watch. The first two lessons of the unit are very vocabulary intensive because you need to become familiar with the terms as we're going to use them throughout when we start doing calculations and speaking in different contexts. So we're going to start off with solution terminology. What is a solution? Well, a solution is a homogeneous mixture. It means one phase. Basically, you have two or more substances in there, and they're mixed together and you don't see the different parts. It looks like it's just one pure substance, but it's not. There's actually two different parts or maybe more, and they're all combined together in such a way that you don't see those different parts. So for example, here we have a solvent. Let's say it's water, and here we have a solute. Let's just say it's salt. I know it's a weird color there, but it's NaCl, let's just say, even though it should be white. We then throw it into the solvent, stir and dissolve, and it looks like one substance. There's nothing settling at the bottom or swimming around in here that we can see. So because we can't see it, we can't tell the different parts, this would be an example of a solution, which is a homogeneous mixture, basically two or more substances that exist in one phase together. So mixing salt and water is a solution. You stir and dissolve, and the salt dissolves in the water, and you can't see the different parts, so you have a solution there. So typically in a solution, you have a solvent and a solute. The solvent is what you're using to dissolve your substance in. So my solute would go into this water here. I'd stir and the solute would dissolve. So solute is what is dissolved, and solvent is what is helping to dissolve the dissolved substance, the solute. Usually another way to look at it is that the solvent is the one that's present in the greater amount, and the solute's the one that is present in the lesser amount. So typically when you dissolve salt in water, like this case, for example, here, water is a solvent because it's doing the dissolving, and that's because it's present in the greater amount. Whereas salt is the solute, and it's being dissolved because it's present in the lesser amount, the smaller amount of the two. And so over here, again, we can see our solution, which is a homogeneous mixture. So if you see a homogeneous mixture, you can also call it a solution. Heterogeneous mixtures cannot be called solutions because you can see the different parts, and the different parts don't mix evenly. In a solution, the solutes will mix evenly within the solvent. So you'll have sort of equal concentrations throughout the solvent, nice even spread and distribution. Whereas the heterogeneous solution, there's no even distribution because all of it kind of settles down towards the bottom at some point. So let's take a look at a few other terms. I've already defined these, but it doesn't hurt to go over them again. So remember that when you have a solution, your solvent is the one that's present in the greater amount, in the greatest amount. So for example, when you have a salt water solution and you put salt in the water to dissolve it, the water is a solvent because it's present in the greater amount and it's doing the dissolving. And the solute's the one that was dissolved in the solvent. So it's the one that was dissolved and is present in the smaller amount. So for example, in our case of salt water, the salt would be the solute. And then once we stir them and everything is dissolved, it has now become a solution, a salt water solution. A solution where water is your solvent is called an aqueous solution. That's why when we used to represent, for example, salt dissolved in water, we'd put NaCl-AQ to show that that was salt in an aqueous solution. Here we have some water. Here we have some glucose. Water is present in the greatest amount. We're going to put some glucose, solid glucose, into the water here, stir, and it'll dissolve, and then we have a solution. So our solvent was the water, our glucose was the solute, and now this mixed together is our solution. We didn't do a chemical reaction. This is simply physical. The water just surrounded the sugar particles. Same thing over here. The water surrounded the ions in the salt. And we'll go and look at more details of how dissolving of molecular and ionic compounds occurs in the next lesson. So let's try a practice example here. So we have orange Kool-Aid is a solution. Okay, it's basically a powder, a Kool-Aid powder, and then some water. So in our case, when we put the powder into the water, we make an orange Kool-Aid solution. The powder dissolves into the water. So maybe you can try filling in the blanks. see if you get the right answer. So the solute would be the Kool-Aid powder, and the solvent is the water. And the Kool-Aid powder is basically just sugar with some flavoring, so I put sugar over here. So one important thing to understand about solutions is that they don't always have to be a liquid solid solution. For example, we see water as a solvent and then glucose, which is solid, as the solute, and then we dissolve them. That's just one type of solution. There's much more than just liquid solid solutions out there. You can have solid solid solutions. So you can have what's called an alloy. An alloy is a solution of two or more metals specifically in their solid states. And so if you look at this part here, it contains some copper, some gold, some silver. In fact, the jewelry you wear is essentially alloy. It's not pure gold. So if you had a ring of gold, there's mixtures of other metals in there to make the gold harder, because otherwise gold is typically soft. So you can have solids dissolved in other solids. An example would be an alloy. You can have solids dissolved in liquids. That is the most common one that we typically think of. Salt dissolved in water. But you could have gases dissolved in gases. So air is a solution of gases. And there's other examples you can find here. So part of what I want you to do is I do want you to go through the examples found at that link to understand that we don't just have solid liquid mixtures. We can have solid solid. We can have solid and liquid. We can have solid dissolved in gas as well. So I want you to go through this and just think of a few and understand the different types of solutions that can exist. And for each one, note down an example that you can remember. So list the different types of solutions that can exist, and then write an example that you can remember to be able to cite if asked for that. But again, you can see a bunch of things that we're not really used to seeing. So here we can see a solid dissolved in the gas. So if you look at this example here, this is called a mothball. You would put it in clothing, for example, to prevent moths from getting to it. And it's made up of essentially solids dissolved in a gas solvent. And that forms a solution overall. So you can read through these and then come up with some examples as well. So here we just have some examples of pure gold. So this would be pure gold, and this would be the alloy of gold. Pure gold is just Au. It's a pure substance, an element. And then the alloy over here will have some gold, some copper, some silver. But since you can't tell the different parts in this area here specifically, that's considered a solution there. And so in this table here, you can just see, again, some more examples of the different types of solutions that can exist. This is not even all of them. It's just some common ones. So you can have gas solutions where you have a solute gas, a solvent gas. So for example, air. You can have a gas solution where the solute is a liquid and a solvent is gas. So humid air. So when you have water vapor in the air, that's an example of a liquid solute, basically the water dissolved in the air, which is the gases. You could have liquid solutions, so you can have liquid where you mix two liquids together, like vinegar. Vinegar is essentially acetic acid and water, or even the alcohol you purchase to disinfect stuff with, that's alcohol dissolved in water. You could have solid liquid, like salt and water. You can have gas liquid, like if you drink a pop, carbonated drinks, that's CO2 dissolved in water. And then you can have your solid solution. So for example, liquid, solid, certain dental components where you have liquid mercury dissolved in silver, also solid and solid. So for example, sterling silver is actually copper dissolved in silver. Other alloys as well are examples of these different types of solutions that can exist. So these are the main different types of solutions. This is a good table for you to know as well. You don't have to memorize every single thing, but know an example that you could perhaps cite for the different types for gas, liquid, and solid solutions. And so, as I mentioned before, summarize the different types of solutions in your notebook that you can find at the link that's provided there. So a few other terms that you need to become familiar with before we go into more depth on solutions is concentration, and then dilute and concentrated. So here we have a beaker with some solutes dissolved in a solvent. And so we zoomed in so you can see the solute. You wouldn't be able to see them otherwise. And so what we have here is a dilute solution. It means that these are pretty spread out. There's not a lot per unit of solution, per unit volume of solution. But if you look at this one, this would be called a concentrated solution. You'll notice there's a lot more particles packed in that same volume. So a lot more particles per unit volume there, so they're crammed together. So a concentrated solution is when you have a large quantity of solute dissolved in a certain unit of volume. And then a dilute solution is where you have a small quantity of solute dissolved in that particular unit of volume. And it really depends on how much solvent you have. So for example, if I were to dump the salt in here into the ocean, or into, let's say, a container of water the size of an ocean or the size of a lake, then that would be very, very dilute, just because it would spread out over such a large quantity of water. So it depends on the volume of water that you have there, or volume of solvent that you have there. That's going to affect the concentration. And that's what the concentration really is. It's the ratio of the solute to the solution. So ratio of solute to solution. So how much solute you have dissolved in a certain volume of solution. And so here you can see some examples of diluted versus concentrated. And you might see it if you make tea, for example. If you let the tea bag soak for a long time, your tea becomes darker because more particles were able to dissolve into that teacup, into the water. But if you don't let the bag soak for very long, then the solution is a little bit lighter in color. And that's because not as many particles dissolved in there. So again, here you can see the difference between dilute, where you don't have many particles of solute per particles of solvent. But here you can see more concentrated, where you have a lot more solute in your solution per particles of solvent there. So they're more crammed in that space. And so those are important terms to know, because we'll be comparing solutions in terms of their concentration. Are they concentrated or dilute? And it's just ways to basically say, like, there's a lot of solute versus not a lot of solute in that amount of solution. And so in the next video, we're going to take a look at some more solution terminology. There, we're going to focus on what solubility is and the different types of solutions based on that solubility definition.